Awesome, guys. Well, thanks for attending my talk. You're in SaltStack at Scale, automating the automation. My name is Steven Gonzales. I'm a principal software engineer at EMC. And you've probably heard a lot of talks today or heard some buzz around people using build servers to deploy their applications or build their applications, test them, and then use Salt to deploy them. This one's going to be a slightly different version. And what happens when you have such a massive amount of SaltStack infrastructure across different projects? How do you actually make those same type of build, test, and deploy pipelines for the Salt code itself that you're trying to get out onto your masters? And so I work in a group in EMC that does cloud services. And so we build and run really big clouds. One of our specialties is object storage. We have some compute as well, but object storage is by far our core competency, right? EMC is a big storage provider. And so what's been pretty neat about this is I work on an entirely distributed team. We have developers, we have SREs, a lot of operations guys, and all of them work on distributed teams as well. So I've had the opportunity to work with a lot of really bright people, and I think part of that is because we're able to hire talent from all over the country and sometimes all over the world. And we are hiring, so if you are interested in developer or engineering type positions, please come talk to us. We have a booth downstairs. And so let's talk about Salt at scale. What do I mean when I talk about scale? And so I'm going to talk a little bit about multiple projects, but primarily I'm going to talk about one project. And this is the project that we actually first started using Salt for. It is an exabyte scale object storage platform. At any given point in the day, it might be ingesting anywhere from 200 to 400 gigabits per second of data. It's deployed in data centers all over the world and is on 10,000 plus nodes and growing. Currently, to support that environment, I think today we have about 14 Salt masters that we're deploying our states to manage that environment. And so, as you can tell by the size of that deployment, this was a tricky project to both get the learning curve to learn Salt as well as deal with all the problems that you have when managing at that size. And so I'm going to talk a little bit about our first run at implementing Salt in this project. So starting out, we started on Salt version 0.17. Insert minor version here. In the beginning, we had two guys who were mainly supporting a lot of the operations for that cloud. I think it probably wasn't at 10,000 nodes yet. It was probably something closer to 5, maybe, I think. We've been using it for about the last year. It went from being used for just remote command execution to beginning to develop the use of states to control that environment. And what a big focus of this talk is going to be on is that we started out with this monolithic Salt repository. And so I still feel like this is probably a pretty common pattern that you see out in the wild for people's deployments. They have one Git repository, and it has a pillar directory and a Salt directory, and it has all the configurations for their project, right? And all their states are in that one big repo, and you might have your little subdirectories that have your different states to organize them, right? And so that was okay when we only used this in one project, right? But as we started to use this outside of that main object storage system, things got very, very confusing for us. And so we had really poor code reuse across projects, as well as divergent versions of the same type of states, right? So some of the issues you would have is we would have, say you need states to manage NTP, rsyslog, your users, SSH, right? Some core operating system fundamentals, right? Not just specific to an application. And so these are needed in every one of these projects to manage the environment. So what would happen is either A, somebody in the other project would start writing their own SSH states to manage it in their environment, or they would copy the states written in another project, right? And then over time, those states would begin to dramatically diverge in what they do. And so what you also got in these states is a lot of logic that was really, really custom to that particular project, which also made them difficult to use in other projects, right? And so this was also really difficult to deploy the pillars and states. Like I said, we had 14 Salt masters, so it's difficult to keep all of those in sync. It's also very hard to test. So when you think about testing your application code, right, you make a change to your particular app, maybe you make a change to your web service, right? And maybe you have another part of your app that handles some queuing and some other data services, right? They're probably in separate repositories. And if you make a change to the web service, what happens, right? The web service might trigger something on your build server, execute tests that pertain to that web service, right? And then produce some kind of artifact or a package for you to install that box. So if I have a monolithic repo of all my salt states in it, and I make a small change to the NTP state, guess what? How do I know how does the build server know what part of the code change and what tests to be executed? Do you execute all the tests for every single state in the entire repository? How long does that take? How do you even begin to set that up, right? And so we're going to talk about ways that we got around that. And so another thing we had was a lack of consistent patterns. And I'll get to this more on some of the next slides, but like I said, a lot of our states had logic pertaining to that project embedded into all of the states rather than that being configurable through Pillar, and a lot of different ways that people access their configurable components inside of their states and templates. And so we figured that wasn't going to scale, right? And I came from a software engineering background. In a previous job, I worked on a lot of Python projects where we were responsible as software engineers of writing the application code, writing the deployment code, writing the tests, and having the entire build cycle. And so I thought, well, we hear a lot of lip service about infrastructure as code, right? And originally, that buzzword meant you can now define what your infrastructure looks like by writing states, right? By writing code to manage that infrastructure. But I'm trying to take it a step further and saying if you're going to treat your infrastructure as code, then you need to treat that code as a software product, right? And so it needs to be subject to version control. You need to use sane design patterns. So for example, if I'm a developer in a regular application, I know what a factory pattern looks like, right? Or a repository pattern. These are things, design patterns other developers are familiar with, and when they look at your code, they get a general idea of what's going on in there. And so I felt we needed something like this for our salt states. We needed better code reuse, right? In software engineering, if everybody's using a database driver to talk to their particular document store, right? What usually ends up happening? It gets turned into a shared library and reused throughout multiple projects that might use that same data store, right? You don't keep rewriting it over and over. And so you also need testing, and you need a way to deploy your code, right? So all this got me thinking that this might be a really good use case for a build system, right? The same way you have a build system that builds your application code, you have a build system that builds and delivers your salt code. And so this is where we said enter the formula. And so if you're not familiar with what formula is, it is usually a standalone Git repository that contains a group of tightly coupled states that are used to manage a single application. And so what that allows you to do is to be able to reuse that code across all your different projects and environments, right? So they promote code reuse, right? Because now I can write an NTP formula, and I can distribute that formula in all of my different projects, not just like test and production environments, but across entirely different projects, right? One might be for object storage, one might be in compute, but they're all going to use NTP. And I should expose the configurations in that formula so that anybody can configure that formula to their desire through the pillar data, right? What we ended doing is that really helped end some divergence in a lot of places, right? So we're all using those shared libraries. We decided project repos, the end goal of this is that project repos should only contain pillar data for that project. So all of your other state logic should be encapsulated into individual reusable formulas, and then your project just contains the pillar that configures that to execute in your environment. And what this also allows you to do is test your states independently. I make a change to the rsyslog formula, I only have to test the rsyslog states that are inside of it, right? But they still need standards, right? Like, I don't know if any of you have ever looked at the open source formulas on GitHub. Some of them are really, really good stuff. Some of them, need a little love, right? Like, it may not be someone's primary objective to work on that particular formula. What you also see is like wildly different patterns in those formulas for accomplishing things. And so internally, we have a little bit of a different layout than you might see in some of the public formulas. So we still have like the changelog files and the version files that you would see on the public repo, but we have a couple of differences. So what I found in some of the formulas that I started to write is that I needed to write custom modules and state modules, right, for providing custom states inside of my formula. Those modules and states really didn't apply to the rest of the Salt infrastructure. They were really for use. They were super tightly coupled with the code that was bundled in that formula. And so I kind of thought, hey, it might make more sense, and I've seen in other configuration management tools, to bundle that type of code that's tightly coupled like that with the formula that you're deploying with. So anybody that installs that formula has the necessary states they need for that formula to work. So as you'll see, we have in our formula repository, we have a modules directory and a states directory, right? We have a Debian directory, and I will get into what that means for us in a couple of more slides. This was a Docker formula, so here you see a Docker directory. And this has your main states. We had a service state, a regular init state, and it has the map.jinja and your templates that you would normally see. And then where it starts to get special here is we have a test directory, right? And so what's in this test directory are a few things that help us build and test these projects. And it helps the developer test them locally, as well as make a reproducible automated test that can be performed on a build server. And so in this test directory, we have pillar data that we use for executing the test. In this file, I have a docker test.py, which lets me write functional tests against the environment. We have a test requirements file so that your functional tests can have their own Python dependencies. And we have a tox file and a vagrant file. And so I'll get into some of the stuff that tox does and nose test does. And if any of you are Python developers, you're probably already familiar with some of these tools. So actually, let me go back one. So one of the cool examples that I'd probably like to touch on for an ideal of functional tests, in addition for testing, like if some value is in a file or if some service is listening. One of the things we were able to do that I liked was a RabbitMQ formula we had. And we were deploying federated RabbitMQ clusters, right? So you had two different clusters that had mirroring between them, but that also had to federate messages back and forth to the other side based on traffic. So it really isn't enough to just test that that package is installed, right? Or that that service is running, right? I need to, this was really crucial behavior, and I needed to test that by setting the pillar values in a way that I had determined that I would get the expected configuration on those clusters. And so you're able to stick things in these type of tests, like place the message on one queue, make sure you can pull it off the mirrored queue. Push a bunch of messages onto one cluster, consume from the federated side, and see that the messages travel over the pipe and that you're able to retrieve them. And on those, we actually made tests. We parameterized them in a way that we're actually able to execute them against the production environment as well after deploying this into production. Actually, these guys did that right here. So let's talk about settings and configuration in your Salt formulas, right? Let's get a little bit of sanity into how our formulas are configured. So this is an example of a map.jinja, which you'll see in a lot of the public formulas. And the primary purpose of that was originally is to contain a dictionary that made an operating system map that allowed you to pull out specific settings that were pertain to particular operating systems, right? So you might have, if you had an Apache formula, right, for your Debian package, it might install a package named Apache 2, but for Red Hat, it installs HTTPD, right? And so you use that map to build in your operating system differences. But we took it a step further, right? We said every setting that's available in your formula should be defined in this file in a dictionary, and it should have a default value, some kind of sane default value. So a lot of times what I saw when looking in public formulas and in our own states internally, sometimes people they did a pillar.get within the state, or they did it within the template, and then if that didn't work, they assigned a default value, or they wrote a macro with some weird logic to determine that was embedded in some template that's in that file. And unless I went through all the templates, I didn't really know that that was something I could configure. And so we have this dictionary that defines all the default settings. So what we end up doing in this map is it resolves, right, when this file is rendered. The OS map resolves for the operating system it's on. We do an update down here where we merge the OS map into those default settings that are operating system agnostic. And then at the very end of the run, we do an update that does a pillar.get on this Docker key, right? And then merges in all your pillar data over those settings. So effectively what you've done is this identified, defined all of your settings in the file, and then you've allowed pillar to just act as an override. So you only have to define the pillar items that you need to configure differently or than available in the default. Yes? So the question was, do we not have a pillar.example in our formula? We do have a pillar.example in our formula, but that is not loaded into your pillar tree, right, when you install a formula. So this is actually like will run on your box, right, and compile when your pillar's rendered and merged in. And so what this also lets us do is this then allows us to have all our states and our templates access those settings from one particular place. So after that map.jinja has resolved all those settings into one place, you can import it into the top of your states or templates. And then you can see here like the package name, right? It accesses docker settings.package, dockerpy.version, right? And so you get to access all these settings from that one dictionary, and that is the only dictionary that you import into your different settings. And so I think that's worked pretty well for us and made looking at someone else's formula kind of easier to understand and to know what's configurable and what's going on. And there's no question about where that data is getting loaded from or when it's getting loaded. So another thing we do with our salt formulas is we use VAGRANT, right? So if you looked at those previous slides where I had the test directory, you notice that I had a directory where I had pillar settings, right? And I had the tests. And so what we do with VAGRANT is we define our box that we want this test to run on. You can define an operating system for it. If you're not familiar with VAGRANT, it's a tool for provisioning VMs. Works really well locally for fast testing. It's disposable, so you define your VMs in a way that you can spin them up, destroy them, and then recreate that same environment. VAGRANT also comes with a built-in Salt provisioner, right? So you can use it to already bootstrap Salt and execute things that you have in this pillar data, right? So if you look up here on this file, I'm syncing folders. I'm syncing over the test pillar data we have. I'm installing the formula onto that VAGRANT box. I'm syncing over any modules and states related to that formula. And then right here, I'm telling it that I want it to provision. I want it to run the high state that I've set. And I want verbose output so that I can look at problems that come when my local testing around the builds. It gives me more information I need. This is actually a simplified version of ours for presentation purposes. Ours has a lot of other parameters about boxes you can use and different environmental settings and controlling how much RAM or CPU that box spins. Yes?
Do you all have a GitHub where you're storing this sort of information for public consumption, or can we get examples?
So the answer is if we had a GitHub where we're storing this information for public consumption. I think I might follow up this with maybe like a public blog post that could be consumed. At EMC, we have to make requests to open source software. I have a couple of open source requests open right now, so I might be open sourcing a couple of these patterns. Because what we do, so if you start looking at all this structure, right, it looks a little complicated. You have to have your test directory all set up. You have to have your map file rendered. Your VAGRANT file has all these configurations, right? But a lot of these are the same for every formula. So I don't know if y'all have ever heard of the Python project called Cookie Cutter. And so we have so Cookie Cutter is a Python project that lets you define a template for creating new projects from Jinja, right? So you should already be able to just jump in and use that pretty easily. So when you create a new formula, it actually prompts you with a couple of questions and then renders that complete file structure and gives you like some default sane vagrant settings so that you can actually like vagrant up and get a box and kind of begin to develop on that salt formula immediately. And that was actually one of the first things we did, was I thought if we're gonna make a bunch of patterns and practices and expect the group to like adopt them and wanna move forward with them, we need to make it as easy to write as possible, right? You can't give somebody a bunch of standards and say this is the right way to do it and then not give them any tools to make that easy, right? And so down here you'll see we parameterize these with some environmental variables. Like for this case, it reads from an environmental variable called salt install args. So something that the Vagrant provisioner lets you do is pin, you can pass parameters to the salt bootstrapper, like of what particular version of salt you want to install. So it is conceivable that you could have your formula building and testing with different versions of salt just by setting the environmental variables on your build server. And so let's talk about the test tools. So I'm pretty sure in a salt community, we have a lot of experienced Python developers in here that have also moved into DevOps or maybe been doing a lot of DevOps. And because of salt, you're now learning Python. So if you've ever worked on a lot of Python projects, you might be familiar with some of these tools. We write our functional tests in Python. I use nose test as a test runner to sniff out functional tests. So that's a pretty common Python tool that you might see for running unit tests or functional tests. And I use talks to build and execute these tests. So I don't know how many of you are familiar with talks, but talks is a testing automation tool, which is also pip installable, which allows you to, and I'll kind of trace through here as we do this, it allows you to install your test requirements from a file. So as you see up here, I have some test requirements defined. I have Flake 8 because I'm actually running some lint against the custom modules and states that I wrote. I have nose because that's what I'm using to sniff out the tests. For this particular example, I had PyYAML because I was loading some YAML stuff to test configs I had provided. And I had the requests library because in some of my functional tests, I'm hitting some REST APIs and checking configurations over HTTP. And so all those have to be installed in order for that to build. So talks will create a virtual environment. For this one, I have it set to use Python 2.7. It will install all of your test requirements into that disposable virtual environment. It will then execute the flake on the modules and states. I then have it run the vagrant up command, right? So when that vagrant up command executes, Vagrant begins to provision those VMs that I've defined in that Vagrant file and execute the salt provisioner on each one of them. And so after that has completed, which can also blow up if your states don't compile, right? Because it can return a bad exit code. Works a lot better on the newer version of Salt, I might add. Some of the older versions, I think you might still pass that phase without noticing. And then it executes nose test, which sniffs out the functional test to execute against that environment. And so, like I said, we've done a lot of cool stuff. We did some RabbitMQ testing. We have a salt formula. That one does a bunch of stuff where it spins up the HTTP API and would set up Syndic and send commands through the API and validate that I can run a test.ping across some minion that I set up with salt SSH. So you can get really into the Vagrant files, right? You can do a lot of cool stuff with it. And then I have just some little Flake 8 settings because if you ever write custom modules or states and you use that salt key or the ops key, it'll complain that that's not defined, right? So how do we install these, right? So we've added a little bit of complexity and we had a little bit of weird requirements around installing these and keeping these in stink. Because remember, this was first going to get deployed in an environment that has 14 separate salt masters. We kind of first played with Syndic a little bit in this regard. We found the network communication to be a little bit buggy. Some of the other major features that I kind of hoped were in Syndic were that I wanted the master of master to get the pillar and states installed, and I wanted it to sync those down to the Syndic masters. But it doesn't do that, right? So I thought about a couple of ways I could implement that in states or recursively copying down directories. And we thought about getfs, right? And so it needs to install somewhere under server formula, right, is our convention. But I also needed to install the custom modules and states into their own directories, right? So usually the common patterns is you have server salt modules and server salt states. So those tightly coupled modules and states needed to get installed into those directories. I also really wanted to support versioning and dependencies, right? I want to be able to know what version of this formula is installed on this box, right? Maybe even auditing tools could pick it up. And if this formula is dependent on another formula, how can I make sure that dependency gets installed as well, right? And I wanted easy rollback. I want to be able to downgrade to an old version of a formula if I encounter a problem, right? And another constraint we had is not every network that our Salt masters run on have access to our enterprise GitHub location, right? So there's a couple of things that ruled out GitFS. That was a major one, right? Not every environment was allowed to have access. There's a lot of different rules around that. And the support of installing modules and states. And in the version of 2014.1.10 of Salt, it was even more limited because you could only specify one route for all of your GitFS links. So it didn't really support dynamically installing multiple formulas into that directory. I think their initial intent was probably like you have your monolithic repo and you put the link and that's where it installs to. And so installing modules and states wasn't going to work with that either. So we tried to think about ways we could do that. Like I said, we thought about, well, I could write some kind of state that runs on the Syndic and it does a recursive sync down to the local Syndic masters and keeps those states in line, and we'll do it all through Salt. But then we thought, I feel like installing code onto the file system, versioning, dependencies, they seem like problems that have maybe been solved before, right? So we said, don't reinvent the wheel, apt-get install your formula, right? So hence why we have the Debian packaging in our Salt formulas. And since that's templated out in the cookie cutter, when you create a new formula, that pretty much just works, right? Like you might make a couple of edits to some directories if you're adding a state or something, like a custom state or something, but for most formulas, it just builds, right? It just works. And so now so we've talked about the problems we had deploying into this large environment, the problems with the monolithic Salt repo and lack of patterns. We talked about how the formula addresses modularity and code reuse and what kind of patterns and practices we introduced when authoring those formulas to make them work better for us, and how we make a way that you can test those formulas and states, right, for your use. And so all that so far has explained how you could run those tests locally. And so now we're going to talk about automating the build and deployment of these. And so one thing that's core to our whole automation pipeline, I think the first formula we wrote was the Salt formula. And so it's different than the one that's on the public GitHub, but I got a lot of good ideas out of that one. It bootstraps Salt masters and minions. It's made to install pillar data and formulas from packages. And so you can set it to install all the latest versions. You could try to pin the versions of particular formulas that you want to. And it allows the Salt masters to high state themselves. So all of our 14 Salt masters in that environment all run a Salt minion, and they're all able to high state themselves off of their own pillar data. So let's talk about a couple of the workflows that we use for this build. So all of our formulas, they're all in their own Git repositories, and we use Git branching to manage their deployment and lifecycle through the build. And so developers make pull requests against the Devil branch. Somebody peer reviews those changes. If those changes are merged into Devil, a build process takes place. They're tested, rolled into a testing environment. If all that works great, then you can open a request to merge those changes from the Devil branch to master. Nobody PRs changes directly against the master branch. So automating this build, we're using a build server by a company called ThoughtWorks called Go Continuous Delivery. It gives us a pretty nice dashboard of build status. It also has pipeline templates. So each particular build of a formula or of any piece of code in this particular build system, it calls it a pipeline, right? And there's a lot of things you can do within pipelines like stages and tasks, and then you can even have interconnectedness between those pipelines. But it also allows you to have pipeline templates. So we also wanted this to be really easy to get people to put their formulas up on the build server. So What a pipeline template as Go does is allows you to render a new project that has all those build steps included in it. And it also kind of works like class inheritance. Any change I want to make to the template will propagate down to all the builds for my Python formulas, right? So if I want to change some common parameter, I can change it for all of them. And then it allows features like variables and other stuff that you can use to override certain things in your build for your formula. And so we have pipelines for both the devil and master branches that we use. So a commit to either one will trigger a build. So this is some of the steps in the build, right? So all the way to the left, and you'll notice this is a Go CD formula. So this is actually a formula that can install the build server. It executes test states, which is a vagrant up and execution of those tests, same as I would expect the developer to do before they submitted this code, right? And validates that all those tests pass. It builds a package, and then it pushes the package into a repository. If this is a build that has been triggered off of the devil branch, it pushes into a testing repository. If this is a build trigger off of the master branch and it passes all the tests, it goes into a production repository. And so just a quick touch on, this is more about what you can do with that continuous delivery server itself by ThoughtWorks. This example is the Docker formula requires that Docker Pi be installed on the system for those modules and states to work. And so what this actually allows us to do is the Python formula will build from any changes to Git that it has. The Docker formula will build on any changes to its Git repo that it has. But I've also got it set up so that a change in the Python formula will then, a successful build will then also trigger another build of a Docker formula to validate that those two still work okay together. There's still a lot of work that we kind of want to do around the dependency management though. So kind of the full pipeline, right, that we've talked about. Developers make pull requests to merge to devil. They build, package, and push to a test repository. It auto installs into the test environment. So in our test environment, the salt masters for that particular, that match that project, right, are set to auto install new packages really frequently, right? So those will become immediately available in that testing environment, and people can go and then they can even do some additional manual testing or playing with those as they go to see how that works. If all that works in that testing environment, then they can make that request to merge the changes from the devil branch into the master branch. And before that master branch package is released to production, it goes through yet another build where it executes those tests to make sure there's nothing weird has happened between that merge. And then those packages are put into a production repo and ready for production. And different projects can kind of choose how they want to install those based on their salt formula configuration settings. They can have their master install the latest of every package or kind of pick and choose what they're trying to do in their particular environment. And so we have some next steps. It's by no means a perfect system. There's always room to improve. We could probably work on this forever, right, and never feel that we're finished. There's still plenty of code to convert over to formulas. So like even in this large project, there's still some states that are in that monolithic salt repo. It's not been completely purged into pillar data. And we have other projects that are in the process of converting over to the use of formulas also and getting divergent feature sets into one formula that can then be distributed. So that's quite a big workflow to take on to do that. But what's been really exciting for me is we recently had a new project that controlled some shared infrastructure that was spun up with its own salt master. And that project has been done, which actually I didn't really work on, but it's been done completely with the project just has pillar data and everything has been done by formulas. So it's been really exciting to see that catch on and how fast they were able to get that running. And we need some improved tooling for formula dependencies. We've been kind of playing around with ideas of how it's easy to get your dependencies installed for local development. And so I think we might have some answers to that, but we probably have a little bit more testing to do before we push that out. And also, we'd like expanded use of external pillar. Not quite as tightly coupled to this, but some of the changes we make could have been calculated by changes in the environment, and so we're kind of looking at ways to explore that. Currently we use external pillar a little bit, but it's more to pull an API that might have a bunch of information about our static, like physical servers, right, that we already know information that's not going to change. Yeah, like a CMDB. And so I just thought I'd throw up some links to the Go server, to Vagrant, to Tox, to nose tests, and to cookie cutter, right? So that if you want to, you could do some research on your own. And so does anybody have any questions? Yes.
Did you guys look at using something like SaltStack to do any type of actual integration testing on the system after you started up? Or?
So we've been kind of playing around with some ideas for that. I wouldn't say that's an area we've gotten really mature at. One tool we were looking at was Fabric and envassert, which performed a similar job to SaltStack. I used SaltStack with another unnamed configuration management tool that I was really deeply into for a long time before moving over to EMC. We've looked at that, but I think in one of the talks earlier, they talked about some new monitoring states that can actually tell you if a process is running or something's listening on a port. So I think we might take some time after this conference to kind of look into that and being able to, the idea of including a test state in your formula that actually validates that in an integrated manner. Then you could include that in your high state, right? And your production environment could maybe run that and alert on it, right? If something isn't running. Yes?
I'm just curious, in your formulas that you have, that as you're adding them into particular server configurations, what are you doing to sidestep or add them to the various file routes? Because I find that a lot of times when I think about salting my salts, I hate the idea of constantly restarting my masters as I'm adding new projects or formulas in.
So adding a new formula, I don't think that requires a server restart. It will trigger. Yeah, it doesn't require a server restart. Making changes to the salt master configuration does require a server restart. Yeah, so we don't really add new file routes very often. So we have a server formula file route, and then the packages install the formula underneath the server formula file route, and then make that available, right? So we have one file route that holds all the formulas that they install to. So that way you don't have to keep upgrading that. Yes?
How do your tests handle differences between specific platforms, or do you just target one platform?
So the question is, how do we handle tests for targeting different platforms? That's been interesting. There's only certain formulas have we made to handle multiple platforms, and that's been based on our internal needs. So the salt formula, for example, does test interaction with different platforms because there's more than one type of OS that gets that salt minion installed. There's some other like really specific formulas to custom applications that we write and maintain where it only like runs on Ubuntu, right? Because that's what we have that application running on. Yeah, I haven't tried out Kitchen Salt yet. I'd be interested to see, because sometimes we do some clever stuff with the Vagrant files to create like some unique test cases, but we've just been doing that by using separate Vagrant boxes for the different operating systems. Yes?
Curious, so you said you had close to 10,000 nodes that you manage, and you have 14 masters.
Yes.
Is there a reason why you have to have 14? Is it a scale issue?
So the question is, we have over 10,000 nodes and 14 salt masters. Why do we have to have 14 salt masters? Is it because of scale? A little bit because of scale, also because of isolated network segments. So there might be certain channels, like as an object storage platform, you have a lot of replication and there's pipes for that, but that traffic is primarily limited to the ports at which the replication traffic travels over. And so that's a little bit of why we have additional masters. So it's been nice though, right? Because we haven't had to really overload a master. I think at some time in the past though, we had to run through the environment and like add CPU and RAM to all the masters. So that we've encountered that before, but I wouldn't say that's been a huge issue. Yeah, and we added some additional configurations for splay and whatnot. We were also doing some really interesting things with Salt, where we were orchestrating some upgrades that were really specific to the product that was running on that box and communicating with its job system. So we were actually writing scripts that would run on the Salt master and call into the Salt API to execute commands and get all this information. And so when we were running those, like we were like running those boxes really, really hard. Is anybody else? Yes.
So when you actually create your salt masters, you talk about different projects. I'm assuming that not every salt master you deploy has every formula that you have on. Can you talk about how, I mean, and they go back to that salt formula that you
Yes, yes.
you just use pillar data then to say, hey, install these dev packages that have all these formulas?
You got that exactly right, but I'll repeat it just so everyone can hear. So he's asking, how do we manage salt masters for specific projects? Do we have to install all the formulas, or how do we manage only installing the formulas we need for that particular project? And it does rely on the salt formula that's bootstrapping that master, and it is configurable through pillar data. You actually supply a list of the formulas that you want it to apt-get install. And so that's how we do that. Was there one more? Yes. So the question is, does our file roots have server formula in it? Yes, it does. It has, most of them have server formula and server salt. Yes, so like, for example, so he's asking how the Debian package installs to that server formula root. So all the Debian packages that we have install under that folder structure. So like a Docker formula would install into server formula Docker, which makes it immediately get picked up by the salt master. And the packaging also does allow you to install your modules and your custom states, your state modules, I think is the proper term for that, into whatever other directory you have assigned for those.
I think you mentioned that you said that your pillar data is also being packaged up. And is it also in Debian packages? And how often are you actually rebuilding those packages?
So the question is, do we also Debian package the pillar data for deployment? And we do Debian package the pillar data, and we actually use, in some cases, package.latest so that the masters will always pull in the latest pillar data. So those packages get rebuilt every time there's a change to the pillar data that is getting deployed to production. So that frequency could be 8 times today, or it could be twice this week, right? It's pretty regular, though. It's pretty regular. So the question is, are we doing any kind of post-install script in the Debian packaging? So we're not moving around modules directories, but when the package installs, like in your Debian files, right, the control where it installs in the install file, you specify what files sync where. So like I'll tell it that the Docker directory in this formula tree gets installed to server formula Docker, and I'll say that _modules docker.io gets installed to server salt _modules docker.io, right? And I'll just specify those in the install file. I don't remember if there's a post-install script in there at all or not. It was a long time. I wrote it a long time ago, and we cookie cuttered it, and I haven't really had to mess with it since. So it's been really stable, so I haven't looked at that particular packaging code in a while. Cool. Any other questions? Cool. All right, thanks, guys. I really appreciate you guys attending my talk.